Hi guys, in today's lesson, you are going to be working with corresponding parts of congruent triangles. We've learned about that before in the past, and we've learned about side, 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 side angle, side, all those different types of triangle congruence theorems. But what we're basically going to be doing today is kind of expanding upon that and basically being able to put some proof with that. The main part of the proof that we're going to be using today is corresponding parts of congruent triangles are congruent. And another way that we're going to see that abbreviated is CPCTC if you don't want to have to keep writing that out over and over and over again. And it's basically just an acronym for exactly what I just have here. It means that once two triangles are proven to be congruent, then the three pairs of the sides that correspond must be congruent, and the three pairs of angles that correspond have to be congruent as well. And CPCTC is usually used at the end of a proof to show that two angles or two sides are congruent. So just to clarify, if, for example, triangle ABC is congruent to triangle KLM, then all the corresponding sides and all the angles of the triangles would have to be congruent, okay? And we could use that to help us to maybe pull out parts if we know that the triangles are congruent to help us to prove something in the future as well. All right, so we're going to use that to help us to plan and write a proof. So when we look at this picture, we might not necessarily see a triangle, but if you look a little bit further, you can actually kind of see that there are a bunch of little triangles that are involved in that picture. So we're given that segment SD, and I'm going to highlight that in blue, is congruent to segment TC. And then we're also given that segment CS is congruent to segment DT. So I'm just going to highlight those in red. We were going to prove that angle SCT, so SCT at the top, and angle TDS are congruent. Well, in order for us to do that, why don't actually we pull out the two triangles that we're talking about? So triangle TDS, so I'm going to look at that one. And I want you to write it as well. So triangle TDS, and then the other one would be triangle SCT. All right, so we already know from our picture that SD is congruent to TC. And we already know, and I'm going to just use the same colors, but this time I'm going to use tick marks, that CS is congruent to DT. We're going to use the fact that we know that triangle TDS, we have to prove right now that triangle TDS is congruent to triangle SCT, and then use that fact to show that corresponding parts of congruent triangles are congruent. Well, if I'm looking at that picture, I actually can prove that triangles are congruent very quickly, because if you're looking at this, look at the bottom. They both share segment ST. So by side, 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 we can quickly prove that triangle TDS is congruent to triangle SCT. So why don't we start actually coming up with our proof right now? So I'm going to say the givens. So I'm going to say that SD is congruent to TC. And I'm also going to say that CS is congruent to DT. And that was because that was given to us. And then based off of our picture and what I just came up with in green, I can say that ST is congruent to ST, and that's by the reflexive property of congruence. And then I jumped right into my triangle congruence, because now I have the givens and I have that final side. I can say that triangle TDS is congruent to triangle SCT, and we said that was by side, side, side. Well, because I'm using side, 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 I know that all corresponding parts of those triangles are also congruent to one another. So all the sides have to match up and all the angles have to match up. So because of that, I'm actually done with my proof. I can go right into saying that angle SCT is congruent to angle TDS. And my reason is going to be corresponding parts of congruent triangles are congruent. And you can abbreviate using that acronym, like I said. And the reason again for that is because if you know that the triangles are congruent, then all corresponding angles would also be congruent. So if you look at triangle S or angle SCT and we look at angle TDS, they are corresponding angles with one another, so therefore they would have to be congruent with one another as well. All right, so let's take a look at the next one. We do have two triangles that are hiding within this quadrilateral. We're going to prove it the same way. So let's start our proof. They have some things already marked for us in our picture. So we have given that angle WYX is congruent to angle ZXY. And we also know that angle WXY is congruent to angle ZYX. All right, so let's see what we actually have here. Okay, so it looks like we have two angles. If we show that those two triangles are probably congruent to one another like we did in the previous step, then we can automatically go and say that parts of them are going to be congruent as well. So I see this side that they share in common. And that side that they share in common is side XY. So by the reflexive property of congruence, I can say that. Now I can make a statement about triangles being congruent. So you always have to make a statement about triangles being congruent first before you can make any statement about the parts being congruent. All right, so I'm going to say that triangle YXW, so I'm going to start with this one. So YXW is congruent to, I have to be careful with how I name this. I go from the angle with one arc mark, so X, to Y with two arc marks to Z. And since I had an angle, I had a side included and another angle, this is going to be angle, side, angle, triangle congruence. Because I made that statement, I have then, because I made that statement, I know that the parts that are congruent, so WX and ZY, see how they're right here in the triangle congruent statement? Since I have corresponding side lengths being congruent, then I can go right into being my proof by corresponding parts of congruence triangles being congruent. In this next example, we're going to actually be using CPCTC 2 times to get what we want. So, and you can see this one, we have that GMJ and HMJ are right angles. And then they're telling us that GF is congruent to HF. So we have that marked. And we have that angle 1 is congruent to angle 2, and that's also marked. We're trying to prove, and look where this is at. Angle GJM, so way down at the bottom, is congruent to HJM. So what we have to plan for this proof, and look what it says, we have to prove that triangle JGM, or GJM, so down here at the bottom, is congruent to HJM, and then use the fact that corresponding parts of congruent triangles to show what we're trying to prove. So that GJM is congruent to angle HJM. So they already have the given for you. What we're going to actually do is we're going to work off of the smaller triangle first to get to the larger triangle is what we want. So let's focus up here. All right, so right now, let's look at that smaller triangle. Since we know we have a side and we have an angle, and we know the reason is given, let's actually prove the smaller triangles are congruent. And we're going to do that by saying that FM is congruent to FM through the reflexive property of congruence. Then we can say that triangle FGM is congruent to triangle FHM, and that would be because we have a side, an included angle, and another side. So by side, angle, side. Because we know that we have a triangle congruent statement, now we can say that GM is congruent to MH because of corresponding parts of congruent triangles. So CPCTC. The next thing we're going to do is we're going to start going towards the big triangles down at the bottom and start trying to prove that those are congruent. So they have given to us that angle GMJ and angle HMJ are right angles. So we're going to say that angle GMJ and angle HMJ are congruent because right angles are always congruent. The next thing that we're going to say is that MJ is congruent to MJ by the reflexive property. And now based on that information, we have a side, we have an angle, and we have another side. So we've just proved that the triangles down at the bottom, triangle GJM is congruent to triangle HJM. Now that we have the triangles down at the bottom being congruent with one another, we can say that any corresponding parts will match up and be congruent. So now we can say what we're trying to say and prove by saying triangle or angle GJM is congruent. The last thing that we're going to be doing today is we are going to be proving with a construction how CPCTC can work. Remember, constructions are what we've done in the past with just an angle with a ruler and a compass to help you to prove that parts are congruent. So in this construction, it shows that angle GHJ is bisected by ray HK. We're going to write a proof to verify that this construction is in fact valid. And remember, a bisection is showing that you have two angles being congruent to one another. So if you look in the plan for the proof, you're showing that triangle HGK is congruent to triangle HJK. Then you're going to show that angle 1 is congruent to angle 2. By construction, you can assume that the following statements are also as given because you're setting your compass as a certain setting. So we can say that HG is congruent to HJ, and we can also say that GK is congruent to JK. So I'm actually going to write down those two statements right now. So I'm going to write down that HG is congruent to HJ. So we have those. And I'm also going to say by the settings on our compass, those fixed settings, that GK is congruent to JK. Okay, so now looks like we have HK being congruent to HK by the reflexive property of congruence. So now we can say that those triangles are congruent because of side, side, side. And now if you're looking at the plan for the proof, we were trying to prove that angle 1 is congruent to angle 2 to help us to eventually show that triangles are congruent ultimately, right? And that we have that HK would be bisecting angle GHJ. Sorry, I'm getting tongue-tied. All right, so we want to say angle 1 is congruent to angle 2 because those are corresponding parts of congruent triangles. And then finally, we're trying to prove that this is a valid construction. So because these are in fact congruent to one another, we've proved that it is a valid construction because by definition of an angle bisector, we've proved that ray HK bisected angle GHJ. So guys, if you look through today's lesson, yes, we're doing a couple different proofs, but the main idea is that you're always proving triangles congruent first, and then you're using corresponding parts of congruent triangles to help you to prove that other parts of it would also in fact be congruent as well.